Now we'll be looking at Chapter 9, which deals with the concept of hypothesis tests comparing two samples, or really two population parameters. In section 9.1, we're going to be focusing on means, but specifically averages that come from independent samples. So for example, just to be sure you've got the definition of independent, two samples are independent if they are not related to each other. They are independent of each other. So in more detail, the first sample is not affected by the second sample. Whatever one sample does not play a role in the second sample. And to further make sure you understand the concept, let's look at a couple of independent populations. For example, the average lifespan of a Honda vehicle should be completely independent of the average lifespan of a Toyota. So we're assuming that these are completely separate car companies not using the same parts. You know, for example, Toyota has the subsidiary of Lexus, so we wouldn't want to compare Lexus to Toyota because they have the same parent company and probably use a lot of the same parts, whereas Honda and Toyota are completely separate companies. And examples of samples that would be coming from dependent populations, where one population affects another, would be the average height of a WNBA player, Women's National Basketball Association, and the average height of children of WNBA players. So to qualify or to make an American basketball team, you probably got to be pretty tall, which means your kids are going to be pretty tall. You're sharing the same genes. In terms of the requirements for testing a hypothesis test about two means that are independent, obviously our samples are going to need to be independent, and also they both need to come from a normal distribution, or remember from the central limit theorem, if they don't come from a normal distribution, if the sample size is 30 or larger, then we can treat them as normal distributions. In terms of the terminology, to distinguish between the two different populations that we're studying, what we're going to do is use subscripts on the symbols. So where we traditionally use N to mean the sample size, we'll use N1 and N2. Sample size from population 1, sample size from population 2. And whatever's deemed population 1 will stay that way. So, for example, our sample average from population 1 has a subscript. Our sample average from population 2 has a corresponding subscript. And as always, we're hoping to know the population standard deviations, but if not, we can always use S1 and S2 in place of those. And then lastly is writing the null and alternate hypothesis. So because we're going to be comparing the populations, we're still going to be starting off with H0 first and H1 second. We're still going to have only equals for H0, the null hypothesis, and any of the three combinations of not equal to, greater than, or less than for H1, depending on how the question's worded. But instead of starting with just the population parameter equal to a number, it's always going to be population 1 compared to population 2. Population 1 compared to population 2.